Hello, Algebra 2 Geo students. This is really our last lesson, new thing for this unit, which is exciting because it's kind of a short unit. And this topic is called radian measure. Radians are basically another way to measure angle. The way that we're used to measuring angle is by using degrees. And years ago, many years ago, like in the dark mists of the past, somebody decided that 360 was a good number to divide the circle up into. There's a lot of reasons for that. Probably the most important reason is that 360 has a lot of divisors. You can divide it into 1, 360 times, divide it into 2, 180 times, you can divide it into 3, 120 times, divided into 4, 90 times, divided into 5, 72 times, divided into 6, 60 times, not 7, 8, 45 times, 9, 40 times, 10, 36 times. There's a bunch more. Not 11, but you can do 12, and you can do 15, and you can do 18, and you can do 20. So there's like a lot of ways to divide this thing up. And that's why we have always used 360 as a number of degrees in a circle, because there's a lot of ways to divvy it up. And so in one complete circle, like one revolution, like all the way around a circle, there's 360 degrees. And the other way to measure it, this is degrees. If we want to divide into radians, the number of radians in a complete circle is 2 pi radians. So 360 degrees is a complete circle, and 2 pi radians is a complete circle. It's just a different way to measure angle. It's not anything besides that. There's a reason why it's 2 pi. We'll talk about that later. But just know for now that 360 degrees is equivalent to 2 pi radians. It means the same thing. This means turning all the way around so you're facing the same way you were before. This also means that. These are equivalent. They have the same value and meaning when it comes to spinning around. 360 degrees is the same as 2 pi radians. Now, if I only want to spin around halfway, so instead of doing this, I do like that. So I was facing this way. Now I'm facing that way. That's 180 degrees. Do a complete 180. It means to turn all the way around. Now, 360 is twice 180. 180 is 1/2 of 360 because it's a full revolution versus a half revolution, which means that if a full circle is 2 pi radians, then a half circle must be half as many radians. And half of 2 pi is 1 pi radians. A semicircle, half a turn, half a complete turn, half a revolution is 180 degrees and pi radians. And you all may remember the number pi as being approximately equivalent to 3.1415926. There's a bunch of numbers. It goes on forever and never repeats. Pi is an irrational number. That's enough. You don't have to worry about the fact. It's actually called a transcendental number, but it's an irrational number, so I don't have to worry about it. So in a complete circle, it's 360, which is 2 pi. In a half circle, it's 180, which is pi radians. And what we're going to be doing mostly is converting from degrees to radians, or from radians to degrees, but we're going to be converting one to the other. So there's a couple ways to think about how to convert these. So one way is to think about what fraction of you can use 360 and 2 pi, but it's just as easy to use 180 and pi. These numbers are smaller, right? They're half as big, so sometimes it's good to think about it that way. But I think about well, what fraction of 180 is 360? That's basically the same question as saying this. It's saying 60 over 180 is equal to what fraction? And you can reduce this. You can cross off the zeros and you get 6 over 18. And you can reduce this. 6 divided by 18 is 1 over 3. Let's divide, be able to divide by 6. So if 60 over 180 is 1/3, then like this number here is 1/3 as big as that number, which means the number of radians that this is going to be equivalent to is going to be 1/3 as big as that number. So you could say 1/3 pi, but that's almost always written as pi over 3. It's like 180 divided by 3 is 60. Pi divided by 3 is the same number, is the same term. And there's like a proportion we can set up to do this, which is usually how I do it, which is you say the number of degrees. I'm not going to do that in blue because that was my radian color. The number of degrees over 180 is equal to the number of radians over pi. And when you get this, you can end up setting up a proportion, and you can solve that by cross multiplying. This times this equals this times this. So we're going to see that in a minute. Actually, I'll do that for this one just so we can see what it looks like. If I was going to solve this problem that way, I would take the number of degrees I have, which is 60, and I put that where it says degrees. So 60 over 180 equals, and then the number of radians is what I'm looking for. I don't know what that is. So I'm just going to say like X or something. I'm going to put that over pi. And now I need to solve this thing for X. This is what I'm trying to find. How many radians is 60 degrees equal to? And you do it by doing this times this equals this times this. So 60 times pi, which is 60 pi, equals 180 times X. So 180X. Now to get X by itself, I divide both sides by 180. Your standard algebra trick there. 180 divided by 180 is just 1. That was the whole point of doing this. And 60 over 180, I already know that a 180 is 3 times as big as 60. So this is just going to be pi over 3 when you reduce it. You can think about like crossing off the zeros again, and 6 over 18 is 1 over 3. So it's 1 pi over 3, which is pi over 3. And this was the same number I got here. So if you're looking for like a good step-by-step process, I recommend you plug things into this proportion here and then solve for the thing that's missing. If you use this proportion, 180 is always going to go under degrees and pi is always going to go under radians. It's always how that works, every single time. This is a good way to a good method for converting degrees to radians, and I like it because it works both ways. Whether you're given radians or degrees, it always works. Okay. Let's try this again, maybe. We can do it with these ones. So I'm given a number of degrees. So that goes over 180 to my proportion. The thing I'm looking for is number of radians, and I put a pi down here. And I do this times this equals this times this. 45 times pi, which is 45 pi, equals 180x. Divide both sides by 180. And I get x equals, those cancel out. Now I have 45 over 180. And you might be asking, well, I don't really know how to reduce that fraction. The 60 was a little bit easier. But basically you can punch this into your calculator, 45 divided by 180. And that is going to equal, if you put that in your calculator like this, you're going to get 0.25, which you may recognize as 1/4. I will show you in class how to use a TI-84 or greater calculator to turn decimals into fractions without having to worry about knowing that this is 1/4. But know for now that it's 1/4. So really I can cross this off and write a 1 and cross that off and write a 4. So really the x is equal to 1 times pi over 4, which is pi over 4. So x is pi over 4 radians. So 45 degrees is pi over 4 radians. We've converted from degrees to radians. Do the same thing with 30. Now instead of 45 over instead of 45 over 180, I'm going to put the 30 over 180. 30 over 180 is equal to x over pi. Again, I'm looking for the number of radians, so I make that my x. I do my cross multiplying. I get 30 times pi equals 180 times x. I'm going to divide both sides by 180. We get the x by itself. This side only has x left. This side has 30 over 180. The zeros go away. 3 over 18 is like 1 over 6. So it's like 1 pi over 6, which is just pi over 6. So now I know that pi over 6 radians equals 30 degrees. This is the answer to this question. How many degrees? How many radians is 30 degrees? The answer is pi over 6 radians. Now we normally, some people will ask me the question like, should I solve this? And by that, what you mean is, should I put this into my calculator and get a decimal? And the answer is no, just leave it like this. Just leave these answers in terms of pi. Leave in terms of pi. Leave in terms of pi, okay? These answers I'm going to want in terms of pi. If I put pi over 6 into my calculator, I get this decimal, which is like 0.52359877, blah, 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 blah. I don't want that. That's like an approximation to this number. This number is exactly pi over 6. Leave it as pi over 6. This is how we convert degrees to radians. You use this little proportion. Now we're going to do it the other way, and I promise you that you could use the same proportion, and you can. I'm going to show you how to do that. Then I'm going to show you a much easier way to do it if you're doing it this direction. So let's do the proportion first. So now I'm looking for, this is a number of radians. It doesn't say that, but this pi over 2 is never going to be a number of degrees. It's always going to be a number of radians. Whenever there's a pi in it, it's going to be radians. So my proportion, let's just go back and look at it real quick, was degrees over 180 equals radians over pi. So I need degrees over 180 equal to radians over pi. And the degrees is what I'm looking for. So I'm going to call that x now. 180, that's a terrible 180. I'm going to write that again. And now the number of radians I had was pi over 2. I'm going to put that right here. Okay, so now I cross multiply x times pi equals 180 times pi over 2. And now to get x by itself, I divide both sides by pi. And so this side is now just x. And it's 180 times pi over 2 divided by pi. But this is like a divided by pi. This is a pretty messy fraction. I don't like it very much. So I'm going to clean it up a little. So I can clean up the top by understanding that 180 is like 180 over 1. So this is like 180 pi. 180 pi over 2, all over pi. 180 divided by 2 is 90. So this is 90 pi over pi. Now I can cross off the pi's because there's one on the top and the bottom. I get 90 degrees. That's pi over 2 radians. So this is the answer. 90 pi over 2 radians is equal to 90 degrees. That's one way to do this. I'll tell you a much easier way. And it's to remember this fact from the very first page. This fact right here. Pi radians is 180 degrees. Pi radians is equal to 180 degrees. So another way to do this, it says pi, this is method 2. So I have pi over 2 radians. Well, pi is equal to 180 degrees. So I can just replace this pi with 180. And I get 90 degrees and I'm done. This is like so much easier than this that it's almost not worth doing this way. And I can tell you that when someone asks me how to do this, I think about pi is 180, 180 divided by 2 is 90. So I recommend that you use this method, but know that the proportion works every time. And it's just like a little more trouble here to get it, particularly because of because of this fraction inside a fraction. That's like kind of a mess. So nothing wrong with doing it this way, but there's so many more steps that there's a lot of more opportunities to make mistakes. And I try and give you guys the simplest possible way to get from point A to point B. Method 2 here is the easier way. Okay, so we can do it again. I'm going to use I'm going to use method 2 to do these because it's just so much easier. So this 3 pi over 4, because I know pi radians is equal to 180 degrees, I'm just going to replace the pi with 180. 3 times 180 divided by 4. Well, you could either divide or multiply first, doesn't matter. 3 times 180 is 540. 500 is divided by 4 is 125 plus 10 is 135 degrees. And this you could put in your calculator or something if you wanted to, that's fine. If you want to do this in your calculator, you could just type this in 3 times 5. Like once you get to this step here, I'm going to write that underneath it. I'll put a little arrow. Once you get to this step, you can just go right to your calculator. You type in 3 times 180 divided by 4, and that's going to give you 135. You can ask yourself if it matters if you divide by 4 first and multiply by 180. You can try it both ways and you get the same answer. I won't spoil a surprise for you. And now this is negative 2 pi over 3. Don't worry about the negative for now. Just acknowledge that it's there and we're going to keep it there. So again, I would replace the pi with 180. So negative 2 times 180 divided by 3. 2 times 180 is 360, so negative 360 over 3, which is equal to negative 120 degrees. So 3 pi over 4 is equal to 135 degrees. Negative 2 pi over 3 radians is negative 120 degrees. These are like, I do those arrows so you know that the question was how many degrees is this, and these are the answers. This many radians is this many degrees. This many radians is this many degrees. So like I said, this is kind of the proportion that I use. I use 180 in pi. You can use 360 and 2 pi also. I use this one. Remember, this symbol here is the Greek letter theta, which pretty much always, I'm just going to write always, represents an angle measure, some angle. And I could use, since I needed 2 variables here, because it's like whether you're looking for degrees or radians, you just plug in whichever one you have and find the other. I used X for the degrees and theta for the radians, but you could use X and Y or A and B or whatever, as long as you remember which is which. Remember, this number here, this symbol here, pi, is equal to a number. It's equal to 3.14159. This is pi. This is not a variable. I know it looks, now we're using Greek letters. You're like, we use all the English letters? We got to switch to Greek? Well, for pi, we got to use the Greek letter for pi because that is what this letter represents, this number. Again, you could use any variable you want there, but I am introducing theta because it's going to become a thing that you're going to have to know and recognize as a variable. That's about it here. The rest of this is just a bunch of examples, which I'm actually not going to do. I'm going to let you guys do these. You're just going to use the 2 methods I outlined above. For these ones, I would use the method where you just replace pi with 180 and then simplify the fraction. And for these ones, I would use the proportion. Prop, meaning proportion. 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 And the proportion again is degrees over 180 equals radians over pi. And this, you're gonna have to solve like a little cross multiplying equation here to get that, but that's how you do degrees and radians. We'll talk a little more about their uses in class or in the next video. So bye guys.